Hi, folks. Thanks for joining us. It's Kyle Brittain, freelance reporter and former wildland firefighter. And I'm joined once again by Mike Flannigan. He's a wildfire expert and professor at Thompson Rivers University in Kamloops, BC. Hi, Mike. Thank you very much for joining us today. We're going to be talking about the crazy wildfire season that we've been seeing across Canada. We've just had an incredible amount of area burned already, especially compared to normal. And these fires have been putting off just a ton of wildfire smoke, impacting air quality for millions of people. Many people haven't even been really accustomed to this amount of smoke in the eastern part of the continent. So we're seeing these kind of apocalyptic scenes in places like Ottawa and New York City. So, Mike, help us to kind of make sense of this. How much area burned have we seen so far this year? And how does that compare to normal?
We're about 4.5 million hectares, which is an incredible amount of area burned. It's bigger than the country of Switzerland, to put it in context. And why is that? Well, look at the temperatures for May for Western North America, and where were the fires in May? Mostly Alberta, BC, and the Northwest Territories in May. Much of the territories are covered with snow for a good chunk of May. So it's incredible. Here's the current situation. It started in the West, and as anyone who's turned on the news knows that it spread to Nova Scotia and then Quebec. And this is an incredibly active year and historic. Do I say it? Yes, I say it. Unprecedented. I'm not a big fan of that word, but it actually fits. Look at 2023 versus other years. It's just a rocket. Okay. And the scary part is the fire season's still well ahead of us. For places like BC, July and August is the fire season. And here we are at the beginning of June, and we're already well past our 10-year running average. So extremely active year. Now, Kyle's put up a graph here, and this is from a paper from a colleague of mine, Shilene Haynes and company. And this is the most detailed work looking at historical fire for Canada in our modern record. Yes, there are records before 1959, but not comprehensive for all of Canada. And yes, starting about the late 70s, we started to see more fire activity, and you'll see a lot of graphs start around 1980, and endpoints are really important for graphs. But we are, if you fit a linear trend, we're increasing by almost 35,000 hectares a year. So looking at running averages, it used to be just over a million for a 10-year running average in the early 70s, and now we're about 2.7 million. So we've more than doubled. And my colleagues and I attribute this to human-caused climate change. We can't be any clearer than that. As we continue warm, we'll see more fire. And we'll talk a bit more about that later.
Yeah, absolutely. So, what's causing this year in particular to be so bad?
Well, it's was dry in parts of Canada, particularly the west. The winter was fairly dry, and in fact, some places the autumn was really dry. So parts of Alberta and BC were abnormally dry or in drought. And then you had that heat wave come. It dried out the fuels, and then we got those ignitions. So I often like to think you need three ingredients for a wildfire: vegetation, we call it fuel; ignition, people and lightning; and hot, dry, windy weather. And boy, did we have hot, dry, windy weather. And unfortunately, we got a whole rash of human ignitions, and the fuels were dry, and there was lots of them. We often see this spring window. After the snow goes, you've got all that dead organic material from the previous autumn. Until things green up, it's easy for a fire to start.
Absolutely. And according to Natural Resources Canada, about 45% of all of Canadian wildfires are started by lightning, with the other 55% being human caused, either accidentally or intentionally set. 80 to 90% of of that area burned, however, it can be attributed to those lightning fires. Is there any sort of sense that we can get this year of that ratio, at least yet, or is it a little bit too soon?
It's a bit too soon, but historically, spring is the active period for human-caused fires. For much of the country, our lightning storms don't really kick in until later May or into June if you're farther north. So humans dominate fire ignitions in the spring, and then lightning dominates in the summer.
Okay, let's take a look at this absolutely incredible satellite imagery from Quebec. This is on June 2nd. We can just see all these wildfires seemingly take off all at once. That was highly talked about on social media following this. Just incredible scene here. And of course, these fires generated a gigantic plume of smoke that was actually the smoke that went on to impact the eastern parts of Canada and millions down the eastern seaboard of the United States. How does something like this happen?
Well, in this case, these were lightning-caused fires, and it's a bit early in the season to see so many lightning-caused fires. And that part of Quebec wasn't in a drought, so a lot of people were saying, "How are these fires starting when there's not a drought?" Well, you don't actually need a drought. Drought, enables and loads the deck, but as long as those fine fuels are dry, and it can carry a fire. And in fact, sometimes I've seen in Alberta where the ground is frozen and you have a running crown fire because it burns the fine needles and leaves on top of the forest floor and then gets carried into the tops of the trees. So just because it's not a drought doesn't mean you can't have raging crown fires like we've seen in Quebec, and they're still burning, especially in the northern and northwestern parts of Quebec.
Yeah, absolutely. I mean, we can see here on this archived lightning imagery here, just starting on the morning of the 1st, check out all that lightning through southern central Quebec there. And of course, that was associated with very, very high to extreme fire danger across the province of Quebec, right?
Yeah, you can get high fire danger without drought because it's hot, dry, and windy. And even if the deeper fuels are wet, as long as you've got those fine fuels to carry the fire, away we go.
Right. Now, wildfire's been around for millions of years. And I mean, these forests in northern Canada are kind of adapted to episodes of periodic fire. I mean, fire can clear out the dead organic material on the forest floor and open up the forest canopy, even open certain kinds of cones like pine cones, serotinous cones that open up only under the heat of the extreme heat of fire. So these trends that we're seeing, though, are we going to see an upset to that balance in the future?
If we continue on this trend, we will, because if you get fire too frequently, then those seeds won't reach maturity. And things like aspen that uses sucker, if you keep on pounding it with fire, it loses all energy reserves and eventually won't survive. So then the question becomes, how much more fire do we need? That's a tough question, but we're on that pathway to seeing more and more fire. But my question is, what replaces the trees? Shrubs, grass. Grass, they can grasslands can burn every year. So as long as you got those three ingredients, vegetation, ignition, and hot, dry, windy, we're going to continue to have fire.
We've been seeing lots of debate online about this sort of connection between climate change and this fire season. Is it accurate to say that climate change is influencing or impacting this fire season in any way?
So climate change is making us warmer. So the warmer we get, the more fire we see. And people say, well, why is temperature so important? And I say there's three reasons. And here I'm not talking about individual fire like the Fort Mac fire or Lytton fire, where wind becomes really important. So the warmer we get, the longer the fire season. The warmer we get, the more lightning we see. As Kyle mentioned, lightning is responsible for the majority of the area burned. And third, the warmer it gets, the ability of the atmosphere to suck moisture out of the fuel increases almost exponentially. So unless you see more precipitation during the fire season to compensate for this drying effect, fuels are going to be drier. And most of the models of the future suggest we're not going to see enough precipitation to compensate for this. In some places, there's going to be less precipitation. Drier fuels really are a key part of understanding fire, because the drier the fuel, easier for fire to start, easier for fire to spread. And it means more fuels available to burn, which leads to those high intensity fires that are difficult to impossible to extinguish.
Right. I mean, these natural climate cycles have been going on since time immemorial, but is there any evidence that human activity is actually enhancing or accelerating climate change?
Yes. And we've been monitoring with instruments carbon dioxide, and the first instrument site was on the Big Island, Hawaii, Mauna Loa. And you can see it's going up and up and up. And there are proxy data sources like air bubbles trapped in ice cores that go back hundreds of thousands of years. And pre-industrial, it was about 270 to 280 parts per million. And now we're over 420 parts per million. The last time the Earth saw 420 parts per million was about 3.5 million years ago, which was a much warmer world, and that's where we're heading. So this is what so-called greenhouse gases. And all this means is, you know, the temperature of the sun is about 6,000 degrees, the surface, and it emits its energy as short waves, okay? And our atmosphere is more or less transparent. It allows the short waves through to their surface. The Earth is about 300 degrees Kelvin, and it emits most of radiation as long waves. And greenhouse gases like water vapor and carbon dioxide are more opaque to the long waves, so it traps that heat in. It's like throwing another blanket on your bed on a cold winter's night. It's trapping that heat. And more greenhouse gases, like we're seeing here, means a warmer world.
Right. And the warming isn't occurring uniformly around the globe, right? Like, I mean, it's kind of happening at about double the rate of the global average here in Canada, and even higher amounts in the Arctic. Like we've been seeing that
3 or 4 times. Yeah.
Right.
In the Arctic. I mean, yeah. So for Canadians, you know, I'm a Canadian, I live in Canada. This is, you know, like the winters might be warmer, but we're paying for it in the summer. You know, I've lived in Edmonton for many years and lived happily without air conditioning. I'm not sure if I could live here anymore without air conditioning. And you can see the year in the top center there, and we're coming to into the 90s now. And the legend is on the top left, and blue is below normal, reds are above normal. And you know, in the late 70s, we can run that one more time. You can see it's kind of salt and pepper, or you know, plus or minus, until about the late 70s, and then it got a much warmer world, especially high northern latitudes like Canada.
Yeah, for sure. And then going forward into the future, we would probably expect this trend to continue.
Oh, and it continues in spades. This time the legend's on the bottom, the year is on the top, and it gets hotter and hotter and hotter. And yes, on the scale in degrees Celsius, that's 10 and 15 degrees Celsius. That's just phenomenal. Now this is an older CMIP 5, and it's RCP 8.5, so it's more extreme. But you know, if we don't get our act together, this is the direction we're heading. So let's get our act together and stop this rampant warming.
Right. So how would that kind of affect our wildfire seasons in Canada if this warming continues at this rate, and these boreal forests and our forests in the northern part of the country just get hotter and our seasons get longer and longer?
More and more fire for one, and more heat waves for another. And yeah, just a much warmer world. And you know, sometimes people say, oh, you know, a few degrees, you know, it's not a big difference. Well, when you get to 5 or 10, it's a really big difference. You know, Alberta would be very much like modern day Colorado, or even New Mexico under some of these scenarios. And so we go into fire years instead of fire seasons, where fires would burn all year long. And that's not as far-fetched as you might believe.
Right. Many folks who are kind of skeptical about this climate connection to wildfires have been citing arson as a possible cause for so many of these wildfires in North America. What do you make of that?
So, you know, as mentioned, more than 50% of the fires in Canada are started by people. And the very, very, very large majority of these are accidental. Anywhere from upper 90% are accidental and not arson. Arson are just a rare few fires. And, you know, there's a lot of fires this year undetermined. They investigate every fire for cause, but because it's such an active fire season, it takes a while before all the causes are found out. But almost all of these are accidental and not arson, despite what you may hear.
Right. And arson fires tend to happen near population centers where they're actioned more quickly, as opposed to some of these more remote lightning fires that are kind of responsible for that greater area burn, because they're happening out in areas where we can't get to them to, you know, enact suppression efforts on them. So, I mean, of course, the other thing that we have to consider is fire weather. You can't you can't burn a forest down that's not extremely dry. And so, I mean, we're going to be seeing these increased incidences of extreme fire weather and longer fire seasons. And yeah, so I mean, that's kind of another huge factor here in the arson discussion.
You still need hot, dry, windy, and you still need dry fuels before fire will spread.
Absolutely. Now, given the length of wildfire seasons and the toxicity of the smoke that we're seeing, how can we, as the public, both in the near term and long term, sort of mitigate these risks?
So the first thing is, the more we learn about wildland fire smoke, the more we realize how toxic it is to human health. Children, pregnant women, people with respiratory issues. Stay inside if it's bad. Get air filters, air purifiers for your home, because if it's a prolonged period of smoke, the air quality inside your house can be worse than what's outside. Get air filters. If you're outside, actually, those N95 masks were developed for wildland fire smoke, and they help a great deal at blocking those small particles from getting in your lungs. And the thing about smoke is, you can live downtown New York, as people found out, and you're not going to be impacted directly by a fire burning your place down. You're not going to use your house to a wildland fire. However, you could be smoked out, affect transportation, sporting events, and your health can be in the tank for days, even weeks. And things have cleared up now, but some of those fires are still burning, and depending on the wind direction, it may return at any time. What do we do? Well, in spring, most of these fires are human caused. They're preventable. Fire bans, forest closures, and they've been employed sometimes too much after the fact and not before the fact. And that's kind of a knee-jerk reaction as opposed to good planning. And hopefully we learn from that and put these in place before the episodes. But, the reality is we have to learn to live with fire and smoke. There's no way around it. Fire is a multifaceted issue, and we need multi-pronged approaches to deal with it. Fire bans, fire smart, education, these are all tools we have to help.
Right on. Let's take a quick look forward at what we may be seeing in the coming days, the next week or 10 days or so here. And we're looking at the 500 millibar height anomaly. We can see here in Western Canada that anomalous high pressure ridge there. And that looks like, if we just get this to advance through, we can see here that it's going to phase out to the east. We also have a little bit of a ridge off the coast there. But what's most important is we can see a pattern change afoot, some more troughing in the western part of the country, and some significantly more troughing there over the Great Lakes region. So, I mean, that should usher in some perhaps cooler temperatures, maybe a more progressive upper air pattern, perhaps even some precipitation. So hopefully that keeps those big, strong blocking ridges away that we've been seeing. I mean, if we go further out in time, we can still see some evidence of that ridging in the central part of the continent there. But in general, it looks like overall, we're going to be seeing a nice bit of a pattern change there, hey?
Yeah, there's changes in the wind. And, these fires are large. Some of them, like Donnie Creek, is over 300,000 hectares. They're not going to disappear, but they're going to get quiet and give ground crews a chance to build the guard. And so this is a nice break or a lull, though the ridge was shifting a bit. We have a few more days, especially in Quebec, and right today in Alberta and BC, it's ripping. Okay, but the shifting maybe towards Manitoba, which has been relatively quiet, and parts of northwestern Ontario, something to watch. But for the next few days, Alberta, BC, and northern Quebec, more fire activity.
Yeah. Well, that about sums it up for now. As always, thanks a lot for your expertise, Mike. If you have any questions at all, please feel free to leave them in the comments section. If you like the video, like and subscribe, and we'll talk to you next time. Thanks.